Hello everyone. I welcome you, dear students. This is Dr. Sanjeev Padvi, and we will be studying one of the very interesting topic for grade 9 geography. And name of this topic is rotation and revolution of course of the earth. In certain books, you will find the name of this lesson is motions of the earth. But here we are more specific, saying rotation and revolution of the earth. Now you must have seen sun rising in the east, then it travels during the daytime, reaches to the highest point in the sky, and then it starts setting. So that means we see the motion of the sun in the sky. You also must have seen moon also rising in the east and setting in the west. Then constellation, different stars also rising in the east, and they all move towards the west and they set. And this is what gives us an idea or a feeling that we people here on earth are stationary and the other things are moving around us. This is why one of the reason why people thought that earth is the center of the universe and other things are moving around us. However, as the time passed and as we got to know more and more about the universe, then we realized that it's not only the planets and stars are moving, but our own earth is also in a constant motion. I repeat, it is in a constant motion, dear student. Please understand one very important thing. If you are traveling in a train and if your train is moving in this direction, you find the trees moving in opposite direction. If you are in a bus or in any vehicle and when you look outside, you find the motion of the people, motion of the objects which are on the road moving exactly in opposite direction, or you get a feel that they are in motion and you are stationary. But in reality, we already know, because we are already in a moving train, it's we who are in motion and the other objects which are outside are stationary, like a tree or a person standing or a car parked. They appear to be moving, but in reality, it's we who are moving. In a very same way, dear students, when you see that the sun is moving in the sky from west to east, now we can conclude that earth must be moving from west to east. I repeat, when you see the stars and the moon and other planets in the sky moving from the east to west, we can conclude that it must be we who are moving from west to east. That means the motion of the earth is from west to east. You will be absolutely surprised to know that at equator, the earth rotates with a speed of 1670 kilometers per hour, faster than the aeroplanes in which people travel. The aeroplanes fly at an average speed of 800 and sometimes even maybe up to 900 kilometers per hour. But at equator, earth rotates so fast that its speed is 1670 kilometers per hour. Now, question is why we don't feel that speed? The reason is very simple, because we ourselves are also moving with that. If you are seated in a train and you are traveling, you feel that you are seated because you find other person opposite to you seated like this. So you feel that you are stationary, but in reality you are already moving with a train. That's why you feel that you are not moving, because you are already in a moving train. Similarly, we are already on a moving earth. So when the earth moves, along with the earth, even we move. And that's why we don't feel that motion of the earth. Now, imagine that you are seated on a motorcycle and that motorcycle is going with a very great speed. Let us say 70 kilometer, 80, 90. The moment it crosses 100, the speed is so high that you find it very difficult to stay there. And you may get a feel that as if you are getting pushed behind. Now, if the earth is moving so fast, with a speed of how much? 1670 kilometer per hour at the equator, why don't we fly off in the air? Why don't we simply fly away from the earth? Answer is, you must have guessed it correctly. It is what? Right. It is the gravitational force, dear student, that is holding us tight. Otherwise, we would have flown away along with this moving earth. Okay, we would have flown away in opposite direction, not along with the earth. We would have flown away in exactly opposite direction. But thanks to the gravity, which is holding us at one place. Now, dear students, okay, the earth is actually performing two motions. Okay, now what you have to imagine that suppose my hand represents the earth, okay, and my hand is now moving. So this is what? This is a rotation of the earth. But earth is also performing one more motion. Remember, earth moves around itself. Okay, suppose this is earth, okay. This earth is moving around itself. It moves around itself. Okay. Now what is important to understand that when earth is moving around itself, it is also moving around the sun. So suppose my this hand represents the sun and this hand represents the earth. So earth is moving around the sun. Okay. But when it is moving around the sun at the very same time, earth is also rotating. Okay. It is also rotating, and along with rotation, it is also moving forward. That means, please understand this. Suppose my this hand shows rotation. So while rotating, the earth is also moving forward. That means if here is the sun and if my this hand is showing you the rotation, but at the time of rotation is happening, it is also moving forward. That means it is performing one more motion called as revolution. Now the question is, what is rotation? As I already told you, it is the movement of the earth around its own axis. This motion is called as rotation of the earth. Now you will be um, wondering what is the speed, okay, or how much time exactly the earth takes to complete one rotation. And you must have heard from your childhood that earth require 24 hours to complete one rotation. Okay, one rotation requires how much time? 24 hours. But in reality, the exact speed is 23 hours, 56 minutes and 4.09 seconds. Now 56 minutes, if I simply add 4 minutes, it will become 1 hour. So 23 plus 1 hour become 24 hours. So because this time is very close to 24 hours, therefore instead of specifying that earth takes 23 hours, 56 minutes, 4.09 seconds, we simply say that earth requires 24 hours for its complete rotation. That means to complete one complete motion around itself. Okay, now this is the globe, dear student. Okay, now if I start making the earth move this way, okay, so when it is moving around itself completely, and when my hand again comes in front of you, the earth has completed one rotation. Now suppose, as I said, my this hand suppose represents the sun. So the earth is moving around the sun at the same time. Okay. So this motion of the earth is called as revolution. So for rotation of the earth, dear students, we need time of almost 24 hours, which I already told you. Now, revolution, as I said, is the motion of the earth around the sun. And please understand very, very important thing, that earth moves anti-clockwise around the sun. So this motion is called as clockwise motion. This motion, which is opposite, is called as anti-clockwise motion. So you can see here in this picture, dear students, that this is the sun. The earth is moving. Now this is the earth. The earth is moving in opposite direction of the hand of a clock. So this motion is anti-clockwise. We also called it by the name counterclockwise. Now here you will find one word written, precision. The meaning of the word precision, dear student, that the axis of the earth also moves around itself. Suppose this is the earth, complete earth, and this pen represent the axis. So when the earth is moving around itself, even the axis also moves, but with a very small speed. So that very, very slow movement of the axis is called as precision. Okay. So now earth needs, dear students, 365 days and approximately 6 hours. 365 days and 6 hours to complete one revolution. Okay, 365 days, 6 hours. Now if I take one more year, again this is 365 days, 6 hours. One more year, 365 days and 6 hours. One more year, 365 days and 6 hours. Now 1 year, second year, third year, fourth year. If I take now 6 hours from first year, 6 hours from second year, 6 hours from third year, and 6 hours from fourth year, I get 24 hours. That means one day. So therefore, in the fourth year, they will add all the 6 hours, and that fourth year will be a year having 366 days instead of 365. And you must be knowing, we call it by the name leap year. Okay. So in this way, we get to know that how sometimes we write down the time of 365 days for one complete revolution, while sometimes we write down 366. Now you know the reason. Okay, students. Now, few important points about Earth's rotation. Very interesting. The first point, Earth rotates on its own axis in 24 hours. Okay, that is the rounded up time. And because of that, dear student, on Earth, we have alternate day and night cycle. So day and night cycle, okay, is happening because of the rotation of the earth around itself. The earth rotates around itself. Now suppose my hand is representing the earth. Now on this part of the earth, the light is falling, but on other side here, it is in a darkness. So here it is light, so this will be the daytime. Opposite side it is darkness, so it is a night time. So when the earth rotates around itself, now the point which was in darkness has now come in light, and the other part has gone behind. Therefore, there is going to be the daytime. So rotation of the earth is responsible for the alternate day and night cycle on maximum part of the earth. Second very important thing, when the earth rotates around itself, what you have to understand, now suppose this is the axis of the earth, and here if the earth is there, so earth doesn't rotate simply like this, okay, this way. If this is the axis of the earth, so this axis of the earth is tilted this way, and now earth is moving around a tilted axis. Therefore, on a globe, you will find that it is shown this way with a tilted axis present over here. Okay, so Earth's axis is not straight. So Earth doesn't move straight this way, but it is tilted like this. So this tilted axis of the Earth has tilted by 23 and half degrees. Okay, it has tilted by 23 and half degrees. Please understand this one, dear student. Look at this part. Okay, this is the tilted axis and this is the original axis. Suppose the Earth's axis was this way, but now it is not exactly vertical, but it is tilted over here, and this angle here is 23 and half degree angle, dear student. Okay, so Earth's axis is tilted. Point number two, okay, that as I already told you, we find the alternate day and night cycle. So half of the earth will be always in light and half of the earth will always be in a darkness. That will happen on maximum part, but not in a polar regions. Okay, polar regions will be 6 months in a darkness and 6 months in night. Okay, why that will happen, that will I will explain separately. But right now we have to remember that on maximum part of the earth, I repeat, on a maximum part of the earth, okay, the part which is towards the sun, there is a day. The part which is opposite to the sun, there is night. Okay, now this imaginary line, dear students, that separates the part of the earth which is in sunlight from the part of the earth which is in darkness. Okay, that line, okay, which separate the, now here will be night, here it will be day. So this line is circular and it is called as circle of illumination. It's called as circle of illumination. Now the third important point, dear student, that this movement of the earth is very important, because during the daytime, now here there will be more light, opposite side there will be darkness, where the temperature will be high. Over here the temperature on other side will be low, and when this part rotates around itself, now here it will be day, here it will be night. So that means we find variation in temperature because of rotation of the earth. Another very important point, that this rotation of the earth is also responsible for unequal amount of light falling on earth. Please remember, there are two reasons why entire earth will not receive equal amount of light. Now look at this tilted part, dear students. Okay, this tilted part. Now if I draw a sun over here, okay, now because now, and here if I draw the equator, so you will find that the northern part is tilted towards the sun and the southern part is tilted away from the sun. The southern part will receive less light, the northern will receive more light. The northern hemisphere will have the summer conditions, whereas the southern hemisphere will have the winter like condition. That means the tilted axis of the earth is also responsible for unequal amount of light that is received on the earth. Because the light is not same, therefore the temperature will also be not same. Remember, dear student, depending on temperature, we find variety in plant and animal life. For example, if I draw here the earth, okay, and if I draw here equator, if I move away from the equator, temperature decreases. So when the temperature will decrease, then it is not suitable for the growth of big plants. So in tundra region, in taiga region, okay, we will find coniferous type of plants, but or there may be moss or very small grass growing. But when I come to the equatorial region, there will be the excellent, very high growth of the plants. It means which type of plants grow at a one particular place also depends upon temperature. Okay, that means it depends upon climate, and that climate again depends upon how much light is received from the sun on earth, because different parts receive different amount of light. There is a variety in plant life, and depending on plant life there will be variety in animal life also. The lives of the animal also depend on plants, that we know. Now, if again here is the equator, dear student, and if I ask you which kind of animals live in frigid zone, they will say the animals having fur on the body. That means what type of animal it will be there, whether it has a fur on body or not a fur on a body, again depends on temperature, and the temperature again depends upon what? The amount of light the earth is going to receive while it is going to rotate around itself. Now, also when the altitude changes, dear student, here you see the okay, depending upon altitude, again here the type of animal, the forest that is growing there will also change.